Hello everyone, welcome back to the video lecture series of Basic Electrical and Electronics Engineering. I am Sajitha. Now let us look into the principle of operation of generators. Generally, a generator is a machine which is used to convert a mechanical energy into an electrical energy by using the principle of magnetic induction. And the coming to the principle of operation. Here, whenever a conductor is moved within a magnetic field in such a way that the conductor cuts the magnetic lines of flux, the voltage is generated in the conductor. And now the question is to know what is going to be the direction of the current. So here we are going to apply Fleming's right hand rule. So take our right hand, just take your right hand and stretch your forefinger, your thumb finger and the middle finger, which are going to be held exactly perpendicular to each other, that is at 90 degree. So just imagine, or you can also keep your hand in such manner. So now we can say that the direction of the thumb finger represents the direction of the mechanical force, and the direction of the forefinger represents the magnetic field, and the direction of the middle finger here represents the direction of the current. So the Fleming's right hand rule will clearly tell us about the direction of the EMF induced or the current produced. So here you can see the principle of operation, which is represented using the picture. So in the first picture, the conductors are parallel to the line of the flux. So here no flux lines cut the conductor, and hence the EMF induced is 0 at 0 degree. In the next diagram we can see that the conductors have moved 90 degree in the clockwise direction, and hence there is maximum cutting of the field with the conductor, and hence maximum EMF is induced, which is at 90 degree. Again at 180 degree the lines are parallel to the conductors, and hence there is no flux produced in it. So at 180 degree the flux is 0. So from 0 to 180 degree we can see that there is no EMF induced in it. Whereas from 180 to 360 degree you can see the exact reversal of the phase, which has happened from 0 to 180 degree. That is diagram 4 and 5 represents. In 4, 180 to 270 degree, where the phase reversal has taken place and the maximum EMF is induced because they cut the maximum lines of force. Whereas from again 270 to 360 degree there is no flux or there is no magnetic field which is being cut by the conductors, and hence again the magnetic field which is represented here is 0. So you can clearly see from 180 to 360 there is a magnetic field, there is a terminal voltage which is generated, but exactly in the negative direction. So as far as a DC generator is concerned, we need the output only in unidirection. So here there is a very demanding need in order to convert the EMF or the terminal voltage in single direction. So for this, what are we going to do? So here comes the role of commutator. When a commutator is used with the conductors, we can see that there is exactly a phase reversal, or the EMF or the terminal voltage which is produced is going to be in only one direction. That is, here you can see from 0 to 180 degree there is only one form of EMF in one direction, and in the other case you can see that from 180 to 360 degree the EMF induced is again in the same direction. So this kind of reversal is possible only if the commutator is present in the circuit, and in the absence of any commutator we cannot get a unidirectional power, and hence we cannot say the name as DC generator. It is again going to be called as the output is going to be in the form of AC. So now let us move into the assessment of it. So what is the rule applied?